Hey everyone, thank you for joining. I am Prashant Pawan Bisipati. I'm a principal product manager at AWS and I work on the SageMaker service team. And I'd love to talk to you today about how you can use SageMaker Notebook Instances to improve your machine learning development productivity. And we'll do a little bit of hands-on discussion on how you could use the tool as well, which my colleague Mani will walk you through. Mani, over to you.
I'm Mani Khanuja. I'm Senior AIML Specialist Solution Architect at AWS. I've been with AWS for 3 years and very happy to be a part of this presentation where, as Prashant mentioned, we'll be going through the SageMaker Notebook Instances. So for that, we'll have the presentation in two parts. One would be the presentation, the other is the demo part. So for the presentation, I'll hand it over back to Prashant, and then I'll come back for the demo. Thank you.
Thanks, Mani. So yeah, let's get started. I would like to talk to you a little bit about what SageMaker Notebooks can do to improve your machine learning development productivity. I'll give you an overview of the service and what it offers. And then, as Mani mentioned, we'll do a demo as well, where you can see things in action. So SageMaker Notebooks is a fully managed notebook offering from AWS. It allows machine learning practitioners and teams to explore data, prepare data, build ML models, and go all the way to production eventually and monitor your models there. What I'll do is I'll kick off things by giving you a quick overview of SageMaker itself. And then get right to discussing our notebook offerings specifically. So SageMaker is a suite of machine learning services and tools that take you all the way from preparing your data, building a machine learning model, training those models, fine-tuning them, and then eventually deploying them and managing those models in production. So on the side of preparing data, you have services such as Ground Truth, Data Wrangler, processing. You have a feature store where you can organize and store all of your features that you build as you develop machine learning models. And then you have Clarify to detect bias and ensure that your models are behaving the way you want them to. Then on the build side, this is really sort of the pivot around which all of these other services work. So here you have SageMaker Studio Notebooks and Notebook Instances, which we'll talk about today. And you have a host of other services as well, such as JupyterLab for free, quick to get started machine learning development environment. You have Jumpstart that lets you start using models and solutions right off the bat. You have autopilot, local mode. So there's a suite of features on the build side that let you kick things off in your machine learning workflows. And then you have training and tuning services. So here you have a fully managed training solution with one of the broadest choice of hardware options for you to use. Very easy to set up, very easy to scale. You also have services like Experiments, Debugger, and Profiler that let you fine-tune what you're training. And then eventually, SageMaker also enables you to deploy your models, set up CI/CD pipelines, do asynchronous inference, batch transformation, monitor your model once it's live. So it really brings all of these tools neatly into one place, which enable you to pick and choose what you need for your specific workflow, and speed things up for your development process. All right, so with that quick overview of what SageMaker itself does, like I promised, let's get into notebooks in particular. So SageMaker comes with two types of fully managed notebook offerings. There's Studio Notebooks, and then there's Notebook Instances. So I want to talk real quick about what these two are and how they contrast and compare, where they're similar real quick. And then we'll go specifically into Notebook Instances for today's discussion. So Studio Notebooks is basically a managed Jupyter notebook that's sitting inside SageMaker Studio. It offers quick start collaborative notebooks. What that means is you can actually kick off a Jupyter notebook without even having set up your compute resource. So you can just start writing some code, and then when you're ready to execute, you can then pick a compute resource. It allows you to integrate with all of the other AWS services for machine learning right from within Studio. So that's where Studio Notebooks really enables improvements in your development productivity, is it brings notebooks together with all of these other SageMaker services that we spoke about, right in a single pane of glass. Notebook instances, on the other hand, are standalone, fully managed Jupyter Notebook instances. So they do one thing, they do that really well, which is you have a managed Jupyter Notebook sitting on an EC2 instance, on a deep learning instance. And you can access this directly from the SageMaker console. All right, so a quick deep dive on Studio Notebooks here before we go to notebook instances for the rest of this discussion. You can launch a Studio Notebook in a few clicks, and they come pre-configured with a host of ML frameworks such as TensorFlow and PyTorch. They even come with a ton of sample notebooks that you can just get started with real quick. You can access EMR clusters and debug Spark jobs directly from the Studio Notebook. You can scale your compute up or down. Maybe you want to start with a general purpose instance, and then when you're ready to do some heavier workloads and you want to train a deep learning model, then you can move to a GPU instance. Studio Notebooks are collaborative. So if you have a team of machine learning practitioners, you can quickly share a snapshot of your notebook with someone else in your team, and they can give you feedback, and you can then come back and edit your notebook again. Studio Notebooks are also customizable. You can bring your own images to the Studio Notebook with packages that are specific to your organization and your workflows. So notebook instances, which is the topic of today, are these standalone notebooks, as I mentioned, Jupyter notebooks. It's your familiar Jupyter notebook environment, except it's in the cloud. The neat thing about that is it comes with the latest Jupyter Notebook software at all times. You don't have to worry about that, about upgrading. It comes with data science and machine learning packages, and it's always up to date on security patches. So it really takes a ton of your own operational overhead of running your own notebooks on your own compute by doing that for you and letting you focus on really building machine learning models and machine learning applications. Now, notebook instances let you scale your compute resources easily as well. As I mentioned before, AWS comes with one of the broadest choices of compute resources out there. We have more than 70 instance types. That's always increasing. And so when you create a notebook instance, you can select which compute instance you want powering that notebook, that Jupyter notebook. And you can start off on a general purpose instance, and as your work develops and you're ready to run larger workloads, you can switch to GPU instances as well. Now, even though this is a fairly simple, straightforward product in the sense that it's a Jupyter notebook on a managed instance, it comes with a ton of customization as well. So especially if you're a team of machine learning practitioners and you need to set up some Git repositories or certain packages that only make sense for your team, and you want to automate that for everyone in your team, you can absolutely do that with a notebook instance. So you would set up an automation script that just installs these packages anytime someone on your team creates a notebook instance or starts a notebook instance. You also have access to the SageMaker Python SDK right there in the notebook. So if you want to set up a training job, once you're done with building your model, you can do that right from within the notebook. And then last but not the least, we have over 200 sample notebooks. That number is always increasing. It addresses a host of use cases that most people will find useful to just get quickly started with. And then you can iterate and customize as you go along. So notebook instances is really great if what you're looking to do is get a familiar Jupyter notebook, but in the cloud with the ability to easily scale your resources up and down, and with the ability to be able to customize your environment in an automated fashion for your team of machine learning practitioners. All right. Um, let's now actually look at how all of this works, what it means to have the latest Jupyter Notebook software, how does that help you build machine learning models in a more productive manner. And to walk you through all of that, I'm going to hand it over to Mani, who will do a demo for us with notebook instances.
So I'm in the AWS Management Console. I just logged in, and this is what I see. So I can go to the search icon, and then I say SageMaker, and I click on Amazon SageMaker. Now on the left navigation, I can see Studio, and this is if you want to go to the Studio notebook, but we'll focus on notebook instances. So on the left navigation, I see this notebook, and I can zoom a little bit so that you clearly see it. And then in the notebook, I will go to the notebook instances. I can also configure Git repositories right from here, or I can launch a notebook instance and then configure it. So as you can see, I already have some notebook instances which are launched. I can see their status in service, and then I can use open JupyterLab to open them. But before we do that, let's see how we can create this notebook instance with JupyterLab 3. So you go to create notebook instance. You can provide your notebook instance names. Let's say demo JupyterLab 3. Then you can select the notebook instance type. For this demo, I'm using a medium instance, but literally you can use any instance you want based on your use case. But remember, you are using the notebooks for writing the code and small experimentation. If you have large models and you want to train them, those training jobs will run on a separate instance. So make sure that you are not using too big of an instances if you're just doing some kind of coding, or if you're just trying some code. So I would recommend to not use a big notebook instance. Instead, use a small one to do some experimentation, and then write the code for the training job. And for writing the code for the training job, you do not need a big instance. You can run the training job in a separate instance. Even if you have like a really large model, let's say with 11 billion parameters, you can still use a smaller notebook instance because that training job is not going to run on the notebook instance. It will run on a separate instance, and we will see in the demo. That would make it more clear. So, and when the training job is completed, it will automatically tear down all the resources. So you're only paying for the amount of time the training job was running. So that's how, these are certain cost optimization that SageMaker offers, which are good to know. So I'd use a smaller instance. And then you have option like JupyterLab 1 and JupyterLab 3. So right now it's showing in preview, but I think by the end of the August or starting September, you will only see JupyterLab 3. And then you will select the platform, which is JupyterLab 3. And I won't go through all the additional configuration because the focus is on JupyterLab 3. And if you want to configure Git repositories, again, you can configure it from here. And then you can create the notebook instance. So now it will take some time to spin up this notebook instance, but I already have one with JupyterLab 3. So let's say this notebook instance, if you click on it, you can actually see that your platform identifier is JupyterLab 3. Right, so that's a quick way of checking that whether my notebook instance is using JupyterLab 1 or JupyterLab 3. Now, you must be wondering, I'm saying a lot about JupyterLab 3, it's new, but what is really offered in the JupyterLab 3, right? So there are a few notable features that are being offered in the JupyterLab 3. First of all, it has an integrated debugger with support for breakpoints and variable inspection. So that's there, and we'll see a demo for that. And then there is a table of contents panel that you can use to easily navigate between the navigate the notebooks. And also, which one feature that I really liked, I like a lot of them because they made my job easy. But I personally really like a filter bar, because when I have like a lot of files and I wanted to quickly search those files, I can actually type in and go to the specific file. So you have like a filter bar for the file browser. And then support for multiple display languages, and you can install extensions through pip, conda, and mamba. So we'll install some of those extensions as well. And I'll give you the demo on how you can install the extension for auto completion. So we'll take a look at that. So coming back to the notebook instances, this isn't pending, but for the demo, we are not going to wait for it to finish the launch. We'll instead open the one which I already have in service. Okay, so it is coming up. So now I can see the launcher. So before we go into the extensions, let's first start and understand what our integrated debugger is. So what I've done is I've created like a little small code to see how the debugger functionality will work. And it's available with PyTorch latest P37 and some other kernels as well. I think it's available for the PyTorch and for the TensorFlow as well. So it's available for all of these, for TensorFlow 3.8 and PyTorch 7. So those debugger stuff is available. So let's take a quick sneak peek into what the debugger is. So as I mentioned, it's an integrated debugger, right? So you can see the debugger, first of all, when you launch your notebook, you can see that debugger icon like over here, and you would have to enable it. Right now, if it's in orange color, it's already enabled. So let me do this. Let me restart this so that I can show you everything in action. So let's say you created a new notebook, which you can clearly go to File, New, and do the new notebook. Or you can go from the launcher and use a new notebook, right, directly from here. So those are the two options. So now let's say I have this new notebook, and I've restarted my kernel, so it will start from the beginning. And then you will see this icon. So if it's gray, it's not enabled. Then what I can do is I click on it, and it will turn into orange. That means it's enabled. And then I can also see the variables, the call stack, breakpoints, and everything showing over here. But since I haven't executed the code, things are not populated. So we'll see that in action. And also what I have is a very simple code to give you the demo on the debugger. I'm just importing a NumPy package, initializing A and B to this thing, variables, and then to arrays. And then I have this custom function, which is not doing much, just multiplying and then adding one. And what I'll do is I'll enable debugger over here, so that when this function is called over here, it should, if I have a breakpoint, then it should stop. So let's see. So let's import, let's initialize our arrays. So you can see that NP module, which is NumPy module, has been loaded. Arrays A and B are loaded. And then let's run this function. Nothing will happen because we haven't called the function, right? And then when I call this function, because I have this breakpoint, it should actually stop. Yes, so it stopped over here, right? So then I can actually step over on the right side. If you can see my screen, the call stack, I can step over. So I can say next, or I can use a shortcut as well with F10 key, and then next, and then it will return the result. And my result is in the variable C, which I can see over here. That C value is 1. That's the result, because when we were stepping over, it returned the result. And you can also choose to just publish it. Like that, simple. So this was just a very small example, but imagine when you are running code and there are a lot of data science code that you're writing or training the models or processing your data, this will really come handy to figure out which variable has what value and why is this variable not showing the value that I want it to. So you can do a lot of debugging with this integrated debugger. So this was about the debugger. And how about those new extensions that you can install? So I'll give you a demo on the language extension that you can add for auto completion. So we'll do that. So it's a language server protocol extension. So it's an open source extension. You can install other extensions as well, but I'm going to give you that demo because that's a really cool feature. I mean, I personally really like it because it makes my job easy when I'm coding. So let's see how first we'll understand how are we going to install that extension. So I can go to File, New, and another thing. There is this, before I begin with that, there is this icon at the bottom where I can click Extension Manager, and I can see what all extensions are already installed. So there are some of these extensions which are already installed, like S3 Browser, and I'll show you how you can install S3 Browser as well. And so you can see all these extensions that are already installed, right? So you can install it from here, or what I'm going to show you is how you would install it from the terminal window. Let's go to File, New, and then Terminal. So I can either go to the terminal from here, or again, I can use the launcher, scroll down, click on the terminal. Okay, so we have this terminal. Now, if we are installing the extensions using the code, let's understand how that will work, right? And just for the demo, let me increase my size so that you can see the full screen. Okay. So now you can see my full screen. So first of all, because we are in the SageMaker Notebook Instances, so first what I need to do is I need to activate the Conda for the Jupyter system. So let's do that. So what I've done with this is I have this Conda activate Jupyter system environment, so I'll run that. So now I've activated the Conda environment. And now I want to install the extension. Then I can use pip install to install the extension or other packages. So in this example, what I'm going to do is I'm going to install the Jupyter Code Formatter, which is the extension, which will help me in auto completion while I'm writing code. And then Black and ISOT, they are just Python libraries. So we'll install that. I've already installed it. So it's showing me requirement already satisfied, but if you don't have installed, then it will actually install and do the work for you. And once you have installed it and you say successful installation, then you go and deactivate Conda. And let me clear the screen so you can see that I'm actually writing this. Now deactivate Conda. So now you can see that it has deactivated the Conda environment. Next, your extensions will not come into play unless you restart the Jupyter server. So then you can click and you can use the sudo systemctl to restart the Jupyter server. So let's do that. So it's now restarting my Jupyter server. And once it's done, you will know that's done. Yeah, now you know it's done because when it restarts, it exits the terminal. So now you have done that. And another thing that you will need to do when you actually start the notebook is make sure that you once you have the notebook, you are refreshing your browser. So let's say you have this file, new notebook, and make sure that you refresh the browser to make sure that it's reload, and then you will see that the extension is installed. And how do you know that it's installed? Let's finish this refreshing part. So you will see this icon, like tornado kind of an icon that you will see over here. This shows that it's installed. And then I can import, let's say SageMaker or the pandas and the NumPy. Let's import these libraries. And then let's say SageMaker dot. And for the first time when you are doing it, it might take like a few seconds to show it, but afterwards it's like it quickly just appears. Like for me, it quickly appeared. And then as I'm coding, I actually see all these, suggestions of what I want to do. And let me quickly show you one example for the demo. So let's say the quick example is, let's say I have this data frame and I want to use pandas to read the data frame that I have the CSV file, and I want to use pandas to read it actually. So then I do read CSV, and I can actually see the code, right? Okay, then I can actually see the whole function, like what are the parameters and stuff like that. Let's say I selected this, and now I want to define the parameters. So then I will just say, okay, file test.csv, and I can read it. So it comes in really handy when I have to see like what are the parameters in my function, how do I do that, right? And even with if you're using NumPy, then it's literally like whatever whatever library you are using, it can actually show you the methods for that once it's loaded. And just to remind you, like when you're doing it for the first time, it might take a little while for the libraries to load, but after that, it's very, very fast. Okay, so you can, I don't have the test.csv file, so it will not run, but I just wanted to show you how you can use the auto completion method with this extension. Now, the next part is sometimes, because with SageMaker, although it supports multiple data sources, right? It can support your data especially when I'm training the model, my data can either be on S3 or it can be on EFS, which is the Elastic File System, or it can be on FSX, which is another file system, right? So my data can be in any of these three. Most frequently, I personally use S3, and I've seen a lot of customers using S3 for their data, for their either raw data and running the processing job, or storing the process data and then storing the data for training the models and so on. So there are a lot of different patterns, but the S3 is the most commonly used one. So let me show you how you can install S3 extension. So similar steps that we are going to follow for installing the S3 extension as well. And once you have installed, this is the name. So first, what I'm going to do is enable the Conda environment, as I mentioned earlier. So we'll quickly go through the demo. And then we'll install the JupyterLab S3 browser. So it's already installed for me. So it's showing requirement already satisfied. And important part is that I have to enable this extension, then deactivate Conda, and then restart my server. So now we'll not restart the server because it takes time. So I have enabled the extension now, and then I deactivate Conda. And then again, last step is to restart the server, which is the same command that I used earlier, but I'm not going to restart it, but I will just share it again. So that's the command, but I'm not going to press enter because it takes time. So once you have it installed, the S3 extension, you will see this bucket icon on the left navigation, as you can see on my screen. So I can click on that, and then it will show me all the bucket name. So I can see all the buckets that I have. Let's say this JupyterLab 3 demo, whatever folder I created, whatever files I have, I can actually see it. I can open this notebook. This is the same notebook which I uploaded on S3 just to show you. So you can see all of that. So you can actually go through, and all this is coming from S3. And the question, how do I know that? Right click, copy path, and let's paste this path. You will see that it's an S3 path, right? So it's coming from S3. So it basically tells you that this is coming from S3 because it has this S3 thing. Okay. So that was about JupyterLab 3. So, and also this quick filter by file name. That's really helpful. Let's say, imagine if I have so many, not just these 4 or 5, that sometimes when you keep working on it, you will have so many files, and then you can just search over here. and then you'll see everything is gone, and whatever I was searching is there. So it's a quick search thing. So that helps, right? These are the small things, but sometimes when you're working, they come in really, really handy. So what we have done is we have gone through the notebook instances so far. We started with actually a presentation. We talked about SageMaker features, just an overview. Then we talked about SageMaker Studio Notebook and notebook instances, what are the differences. And then we were talking about that JupyterLab 3 extension, JupyterLab 3 is available for both Studio Notebooks and notebook instances. With the focus on notebook instances, we saw how you can create a notebook instance with JupyterLab 3 and what are the new features that are offered by JupyterLab 3, how you can install extensions, let's say for language completion or S3. So we saw that. Now it's time for real coding, right? Because what we want to do, the next part is, now I have JupyterLab 3. Now let me do the work where I want to have the data. I will train my model, want to do some experimentation, and then based on my experimentation, I'm going to push the best model into Model Registry, which is a central catalog for storing all the models. And you can also add the metadata around the models. And so the Model Registry also offers an approval workflow, and we'll see that in the demo. And once it's approved, you can actually deploy the models directly from the Model Registry. So with that, let's go to the Model Registry. Quick thing. So the code that I'm showing you for the Model Registry is actually available on SageMaker Examples. How do you go to the SageMaker Examples GitHub? So you see this brain icon on the left navigation, click over here. Then you have these different categories. You can actually go and view in the GitHub as well. Then it will open the GitHub page, which I shouldn't have done it, but coming back to our notebook. So it will actually show you this GitHub page when you click on it. So make sure you do right click and open it up in the new new tab. Okay, so now you can see all these headers like introduction to algorithms, and then you go scroll down and go to then we have SageMaker Experiments. So we are using that job. Hold on, it wasn't that far. And sorry about quick scrolling. So we have the debugger stuff, ground truth jobs, inference recommender, inference. So there are a lot, as you can see, there's a lot of open source code available to you. A lot of examples, right, that we can see. And now we have SageMaker Experiments, finally. I thought that was quite above, but you do literally have to scroll it down. So you can see the two notebooks over here. They both are the same. One is with the outputs and one is without the outputs. You click on it, and then you say create a copy, and then you will see the copy in your notebook instance, and you can select a kernel, or you can say no kernel. Let's select it. And then once you're done with that, you go to this folder icon and you can actually see. So you can see this one is like seconds ago. This was modified an hour ago because I already worked on that one, but this is the new one and you can see it over here. So, and when you were, when I was creating a copy, you had an option to change the name. So you don't have to use the same name, but generally if you don't do it, it will just do the name of the name that was showing when I was doing it, and then it will add the date to it. So as you can see, this one is added on 16th August, this one is added today, but I already have it. Let's use the previous one. And this one is with the outputs. So let me go through that. And this one is without the outputs. which I actually ran through it successfully this morning, so it was working. Okay, so now let's click on the one with the outputs, and then I will close this and maximize on my screen. And those of you who are already familiar with notebook instances, you can actually change the way it looks. I know it's white background. Some people prefer black. Then I can go to the settings and change the theme. So you can go to the dark. It will change it. But for the demo, I'll just show the white one. Okay. Now, in this particular notebook, what we are doing is we'll create a SageMaker experiment. And the data that we are going to use is the handwritten digits, MNIST handwritten digits, and then we are going to classify them. So that's what we are going to do. And we'll train a neural network, which is convolutional neural network for images. And then we will use the search and analytics capability of SageMaker Experiments, because we are going to run multiple experiments, and then we push the model into Model Registry and then deploy it from the Model Registry. So let's take a look. So first is that, I'm just installing some modules. I'm updating SageMaker. I'm installing SageMaker Experiments. So let's get past that. Then I'm installing Torch. And another important point, the kernel that I'm using is PyTorch P38. It also works with PyTorch P36. So that's a quick thing. If you want to change, you can change it from here. Okay, then I'm installing Torch, Torch Vision, and updating SageMaker. So we keep launching new features in the SageMaker, so it's a good idea to upgrade it. So once we are done with that, we need some setup. What setup? That we need to identify, we'll import some libraries, and then we need to have a SageMaker session because we are using SageMaker, right? And then region name, role name, this role will be passed to our training job for training the model, because remember, the training job runs in a separate machine learning instance. So that instance needs permission to access your S3, your container, because behind the scenes, it's all containerized. But you don't have to worry about, oh, I don't know containers, how will I use SageMaker? That's the whole point. You don't know containers, but even if you don't know containers, you can still use SageMaker. It uses it behind the scenes, but you don't have to know it. If you know it, well and good. If not, don't worry about that. Okay, so that's what the guest execution role is. It's just literally giving permissions. And then first we will download the data set. Again, this is all Python code. We are just downloading the data set from the URLs, train set, test set, and all that. So nothing much over here. We are just downloading. Then I can see how the data looks like with the matplotlib. So this is just a quick check. And then once I'm happy with the data, because when I downloaded, it downloaded on my notebook instance. Now what I'm going to do is then I'm going to upload it on S3. So you can use the SageMaker session.upload data, and then you can provide the path, the bucket, and the prefix. Prefix means, okay, let's say my bucket name is a test bucket, right? And inside that test bucket, if I want to store the data at a specific location and want to create the folders, so that's what the prefix is. So whatever I provide as a prefix, so inside that bucket, and then the prefix, like which folder is inside the bucket, it will upload the data over there. And then now let's track the parameters from the data preprocessing step. So this is just for tracking and logging the parameters. And now what we are doing is setting up the experiment. Why? Because when we will run a training job, one option is I can just have one training job. I create the SageMaker estimator, provide the parameters, and start the training job with the hard-coded parameters. In this case, we might want to do some experimentation and run multiple training jobs together, or maybe one by one, depending on how you want to do it. So you can create experiment, and you can provide. In each experiment, you can choose to provide different hyperparameters. And again, it is not automatic model tuning, which is different. This is if you want to create your own custom experiments. That's what we are talking about. So first, what do I need to do is I would need to create an experiment. In that, I just provide the experiment name, the description, and SageMaker client. That's it. So it creates an experiment object for me that I can see, and will add this metadata like the experiment name and description. Right? Now, Once I have added the experiment, inside the experiment, whatever number of training jobs that I run with different parameters, I want it to be there under one experiment. Meaning, when I talk about number of training jobs, we are basically saying number of trials within a experiment. So a trial really corresponds to one training job or one processing job. So the next step is that we will create a trial component. So again, just loading the SageMaker PyTorch and PyTorch model. PyTorch is the estimator. So if we are using SageMaker.PyTorch import PyTorch, this will be used for training. This will be used for deployment. Now, when we say PyTorch, and I'll explain that when I'll show you the estimator, you can specify which version of the PyTorch and all that. So when the training will launch into that ML instance, it will automatically launch the PyTorch container with framework version that you had specified. So that's what I meant. Like, if you know about containers, well and good. If you don't know, you don't have to worry about that, because SageMaker, you just need to know how SageMaker APIs, and then it will automatically do that for you. Then I will create a trial component. And so with this, I can say, okay, now what I want is with each training job, I want to give a trial name, and I want to create a number of trials. So I can say my trial name, right? So whenever this training job runs, and since I've added this timestamp, it will be a new trial name. So it will use this object trial.create, trial name, and the experiment name. As long as the experiment name is the same, all the trials created will be wrapped inside this experiment. So one experiment, I can see all the training jobs of the trials associated with that, right? And in this particular case, what we are doing, why we are using this for loop, is because in each trial, we are just using different hidden channels in our CNN model. Okay, so then I'm adding the trial component to the trial. And now what we will do is, in our estimator, when we train, we are going to add this trial component object. So when we do estimator.fit, then inside this experiment config, I will add the trial name and the display name, let's say training. So that's how it will know that the different trials for the different training jobs, right? Okay, so let's understand what this estimator is before we move forward. So this is an example where I'm using PyTorch for training a convolutional neural network, and I'm bringing my own script, which is mnst.py. So this is my own model. So if you go over here, I can actually see my own script, and it can be any training script. In this case, we are using the CNN module. So I'm just creating creating a class, which is basically my model that I'll be using, then the data loaders and all that, and the sampler. So it's basically the training code that I'm creating, and this SageMaker is actually using that training code. So when I do, when you provide the name of your entry point, so it's expecting the training code. So this is an example where I'm using the AWS built-in containers. I'm using in script mode where I'm bringing my own algorithm. So there are different ways. One option is you can select the built-in algorithms provided by AWS. In that case, you will just provide the estimator class, the algorithm name, and you fetch the container for that, and then provide that to your estimator. So in that case, you can just all you need to do is provide the data, use the algorithm, and then you will get the training and start training job. And then you can evaluate the model and then choose to deploy it. Or you can use the built-in containers offered by SageMaker and use your own algorithm. That's what we are doing right now. And the third option is you might say, I want to bring my own container. So you can do that also. But we are using the second option where we are using the built-in container provided by AWS, in this case, PyTorch container, and bringing my own algorithm in the form of a script. So in this class, what I need to provide is the Python version, which is Python 3, the code, training code, role, because again, the job will launch in a separate instance, so we need to give permissions, right? then the framework version of PyTorch. And if you're unsure, you can just use latest, and it will automatically take up the latest PyTorch version that is supported by AWS, because we are using the built-in algorithm. And in case you're saying that, okay, I want to use the built-in algorithm, but I have some extra packages that I want to install, you can do that also, where you can provide source_dir as a parameter. And then inside that folder, you can have your requirements.txt, and whatever packages you have mentioned over there, it will automatically install those packages on this container. So yeah, a lot of options, right? And all those parameters and stuff, if you're wondering, where do I go to see that? There is a whole Python SDK for SageMaker. You can actually go over here, and then you can see, you can actually say, okay, estimator, and you can search. If you want to see like the whole documentation, so it's the whole SDK guide. So you can actually go, and then I can see the different parameters, and the explanation for each of these parameters is available over here. Okay, getting back to our demo. And then I provide the hyperparameters, different hyperparameters, and if you would see this one, the hidden channels that we are passing hyperparameters to our training script will be different with each job, because we are doing it in a for loop, right? So we are creating number of experiments. And then I can also provide metric definitions, because when my training job will run based on what I have in my training script, I might be looking at training loss, test accuracy, or the test loss, or validation accuracy or loss. So depending on what I'm doing, I can actually fetch those definitions from the training job itself, so that it can show it on my CloudWatch logs. So you can just provide the regex expression based on what you have provided in your training script, like when you are calculating that stuff. And then you enable the metrics. So this part, what I have shown you, the estimator, we have only created the object, and we have provided a lot of stuff. We have provided like on which instance we want, how many instances we want the training job to run, and which instance type I want the training job to run. And remember, there are a lot of options. This is just one example. You can choose from different CPUs to GPUs. So you have a lot of options for the SageMaker instances on which you would like to run the training job, depending upon your use case. And then you would do estimator.fit. You provide the input, like, because I need to have the data on which the model will be trained, right? So in this case, it's an S3 path of my input data. Remember, we uploaded it to the S3 bucket, our data, when we downloaded it. So it's that path. And then the job name, the experiment configuration, so that it create all these different training jobs that will run. In our case, I think it will run 5 training jobs. And then we can actually do some analytics and see which one is the best one. Okay, so it will start the training. We have already done that. And now what I can do is I can do some analytics. I can provide my custom filters, and then I will use this experiment analytics API, provide the experiment name, the search expression that I want to sort by, and then I want to sort by the metrics. In this case, my test accuracy.max, so that I know which one is the best one. And the order is descending, so the best one will show on the top, because accuracy we want to maximize. If it was loss, we want to minimize. And then when you run, you can actually do .data frame, and then you can see in a data frame format that this was my trial component name, the metadata around it, which optimizer it used, and what was the training test accuracy, because we were maximizing on that. The test accuracy last, sorry, this one. So you see the 97 is higher. And the associated metadata around it. So you can see all of that, the artifacts and all of this information, and the experiment and the trials and all that. So now I have this. What I want to do is, in this case, there were 5 jobs, but I don't want to manually pick up, right? So I just want the best job. So you can do that, and we'll see it in a moment. And then if you want to, now we are creating like a lineage table. If this is just, the name, you can do experiment analytics. You can change your search filters, and then you can see different options. Now, let's say this is good, but now what I want to do is I want to fetch the best training job and push it to the model registry, because that's what I want, the best model, which will be my potential model for deployment. And then I can store a lot of metadata around that model. I can have different versions of the model within the model package group. So the way model registry works is it's a central catalog where you can have different versions of the model. You can have the metadata associated with the model. You can actually track back which training job was associated with that particular model. You can see the model metrics. You can have an approval workflow, and we'll see that. So there's a lot that model registry offers, and it manages all the models from you for you. So the first concept is the model package group, where what I'm going to do is this. For example, in this particular case, I have this handwritten digit classification, right? So in this scenario, I will create one package group which will maintain different versions of my model. So I'm using this API to create a model package group, provide the name and the description. So once that is done, what I want to do is get the best training job. So from my analytics data frame, what I've created, I'm fetching the best training job. So this is my best training job. Now, what I want to do next is, with the best training job that I already have in this object, I want to register the model into model registry. How would I do that? I have this best training job with me, and then I will use this best training job and create a model object. I'm not deploying it, I'm only creating the model object where I'm providing, okay, this is the model data, like after the training, the model artifacts were stored on S3, so I'm providing that information with script, version, and all that stuff. And then I would do model.register to register my model. And I can, as you can see, I can provide so much metadata. And the approval status, because you can add an approval workflow. So we can starting with pending manual approval. So it is pending manual approval. So when you describe that package group, you can actually list the models within the package group, different versions. So we only have one version. You can see from the API. And then you can see the approval status, which is pending approval. And then if it's pending approval, you cannot deploy it. So you first have to approve it. So I can use the API to actually approve my model. So now I'm updating the same version to approve. So once it's approved, then I can only deploy my model. So once it's approved, what I'll do is I'll use the same model package API .deploy, and it will deploy my latest version of the approved model automatically for me. So that's how I can make sure that even if I have multiple versions of the model, I can see it at one place. I can add a lot of metadata. I can also add whether it's deployed, like you can add description and add stages, whether it's deployed or not. And in the end, if you're using it, using the same notebook and trying it out later on, make sure that you do the cleanup, otherwise you'll be charged, because it will actually create an endpoint and you need to delete that. So there's code added to it, so make sure that you run that. So that was all about today's session on how you can use notebook instances, JupyterLab 3, install your extensions, and then also look into how you can do experiments and model registry, where you can store all the models, create an approval workflow, and directly deploy your models from the model registry.
All right, thanks, Mani. Well, yes, I hope you found that useful, and you've been able to pick up a few tips and tricks on how you can use notebook instances to increase productivity in your machine learning workflows. You can always go to the aws.amazon.com SageMaker Notebooks webpage to learn more about this service. And feel free to reach out to Mani and I if you have any questions. We have our Twitter handles up there. Yeah, thank you for joining. It was a pleasure talking to you all.
Thank you. Have a great rest of your day. Bye-bye.